Alright guys, welcome back again to another exciting tutorial. I'm so glad to be here. So in this tutorial we will take a look at what uniform distribution really means. Like I said, all this distribution gives us that's why it's more or less like probability and statistics. This is the mathematical aspect of data science. Okay, fine. You will have to understand every single of this distribution. This is what you will be able to this is what you need to understand, is because this will gives you an insight of what and how to apply some things in a real world scenario. So imagine if I say everybody have the chances of waking up the next day and it's normal, so that distribution is uniform distribution. Like, okay, fine, used to describe probability where every event has equal chances of occurring. All right, so it has three parameters, and then the first parameter is lower bound, which the default is 0 or 0.0, and the upper bound, which the default is 1.0. So if the probability is chances is high, that means it's going to be 1.0 the default, and if the probability is low, that means it's 0. And it's as shape, the size is what we normally use to do shape. So we've been dealing with a lot of with numbers of distribution. The previous tutorial, like the first one is the normal, the second is binomial, and the third one is the Poisson, and this one is what, uniform. And let's take a look. Without no further ado, let's try to create we need to create let's import numpy rather. So what we're going to do is we're going to say from numpy import random. So by the time you do this, let's run the code and let's figure it out. You see, the module it deals with anything that has to do with random, so that's why you need to import this particular module if you want to make use of all this library, all these methods and distributions. Okay, fine. Let's say x now is equals to, I will do our thing, just a random dot uniform. All right, so you should have gotten used to this concept if you've been following along with the tutorial. Okay, fine. Uniform. All right, these will give you an insight of saying, okay, fine, I say the size is equals to open and close brackets, because we need to do the shape, and we have 3 and 2 and 3, so probably 2 and 4 or something. All right, by the time we run this, let's check it out. What is going to happen? Does it have an error? Fine, it doesn't. Let's print x now. Print x. Repetition create automatism in the brain. You have to practice this a lot for you to get used to it. The way I'm typing it right now, that looks as if, oh fine, it's pretty much easy, is because I've done a lot of practice behind the scene now for understand this, and I've been doing it for years. So you don't need to do it for years, because this is what I do for a living, but you just have to practice it. By the time you practice it, there's nothing there for me to be doing this. You can do better. So let's run the code. Okay, fine, it gives us this number. Don't forget, it's anything like this, because uniform is more or less like the way we did rand and random int. Rand it's probably for all these 0 to 1. You can see. So okay, so this one is also from 0 to 1. So this uniform random number can be generated. So if I reload this and probably reprint this, all this number will be changing. That's how we do our thing. That's what has been happening so far. You can imagine changes is 0, 0.5, 0.5, 0.8. Let's see whether this is going to change by the time we run our application again and we run it again. Okay, so it's changing. Okay, fine. That's the concept of the random module. All right, so what we're going to do next is that we are going to see whether we can probably import some other libraries like matplotlib. Don't forget, I like to say this thing out because this is what I've been doing for a long time. I like to say it out. Like, okay, fine, I'll just say import numpy as mp. All right, and I will say import matplot. That's lib.py plot matplotlib.py, you can say pyplot. Okay, just imagine the way when you say it out, I think you are not going to be mixing it up. PLT. So when I say pyplot as PLT, you get used to it. So when I say matplotlib.pyplot as PLT, like the way we normally say import numpy as mp. So we're going to say import cborn, like the way c like a c born as snls. All right, so we're used to this, so let's go run our code, and it's running, and let's see whether we can use cborn to create something. cns dot dist plot. Right, cns dist plot. Dist plot is that what Seaborn normally used to display the graph. Okay, so we'll just say random dot, don't forget, because we're using uniform this time around, just say uniform. And here we just say, because we're using uniform, size is one of the parameters that this normally has, so that's why we are putting it in there. So I say parameter equals what, 100. So by the time you do that, okay, let's say 1000. So by the time you do that, we can run the code and let's figure out what this thing is going to give us. I'm not always afraid to see bugs, so for me to know what exactly I'm doing or what I'm not doing well. Sometimes, because this thing is getting outdated, this plot is getting outdated, there are some updates that people are now using now, but for the purpose of the Genesis, let's stick to this. Don't worry, ignore all these warnings. Don't worry, ignore the warnings. All right, so what we're going to do right now is that, okay, sometimes you will see some articles just say prt.show. It's not going to change any effect. That is the way we've been doing it before. So let's run it right now, and by the time you run it, it's still going to give you the same result. Okay, so I can decide to remove the histogram, the way we normally do our things. Let's remove the histogram. So I will just say I want to remove the histogram. Okay, I will just say east. Okay, I'll just say east. Okay, when I say east, I'll just say I want it to be false. All right, so when you do that, I will just run the code and see whether this thing is going to be removed. You can see the histogram has been removed. All right, so sometimes if you want to ignore the histogram, you can remove the histogram, and sometimes the reason why you are saying this error, I will let you know right now. So let's run the code back. The histogram is going to be back. Okay, but sometimes they are ignoring this kind of lines. They want everything to be in histogram. That's why they are saying we should ignore this plot, or we should use this, and we should adapt to using this plot instead of this plot. So in this case, if I should remove the t, that's the difference. Okay, if I should remove the t, and I say this plot like this, like this, which is said, if you look at this one, they said this plot is deprecated function and will be removed in the further version. Please adapt to your code to either this plot. Okay, so if you want to adapt the code to this plot, so that probably some people might be having this feeling, I don't want to be seeing this in my code any longer, it's hurting my eyes. You can decide to probably use this plot. Okay, fine, let's use it and let's see what's gonna happen. Good, you can see it's removed this automatically, so you have this clean and elegant design in your so this, you can also predict this. Okay, fine. So but here you cannot use histogram again. You cannot say you want to remove histogram again, like if you do this. I just want to explain this because I've been receiving some messages that they don't want to be seeing that kind of errors in their project. All right, so by the time you run this, it's going to have some kind of error because this does not accept removing, because it's basically histogram, so you don't have to remove this. So let's run it back and let's add this. So okay, you are good to go now. So you can be using this instead of using this. You can get used to using this. All right, so that is that on that. You can see how pretty simple this thing is. If you can do this, I'm assuring you that you are already a certified NumPy data scientist. You've already mastered NumPy. Some people use this and earn a lot of money trying to probably create analyze data with NumPy, pandas, and these. They don't do anything other than they do is just to use pandas and NumPy. And every of our aim is to make sure that we are certified NumPy data scientists. Okay, fine, we're good to go. This is where I'm actually going to stop for now. Hope you enjoyed this tutorial, but let me just go back what I've been doing so far. All right, what we did is that we were able to understand the concept of uniform, and we know the reason why we need it. I don't want you to cram this, just understand the functionality, the main essence of we having that. So whenever you have uniform, it's just the probability of any event, the probability that tells us that the event can happen, have equal chances of occurring. So by the time you are trying to read some word problem, trying to figure out how to solve a particular problem, how to analyze some data, and you're having the feeling that this particular event can happen, they have equal chances of happening. So that the kind of distribution you're going to use is what? Uniform. So that's exactly what I want you to figure out. And always understand the fact that this random that we are using is just for us to be able to generate random number, and the random give us access to be able to use uniform what functions. And this uniform function has two parameters, and you can use the size and the word lamp. Okay, fine, we're not using lamp right now because we don't have chances of creating an event that probably is going to happen or not, but trust me, that's exactly what you need. If you can do this, import this, you run it, and it's going to work perfectly well for you. All right, so in the next tutorial we are going to dive into something more awesome, and I can't wait guys, I can't wait to take you there. We are already getting done with what? NumPy. So what are we going to look at in the next tutorial? We're going to take a look at what is called logistic distribution, and until then, I can't wait to have you in the next one. Have fun. Bye.